Awesome. So the question that we're working on is basically a polynomial with arbitrary degrees of a and b. Just going to put that down here. It was x to the power of a and 1 minus x to the power of b, right? Is that correct? And it was from observing from 0 to 1. That's the idea. So I'm pretty sure you guys can figure out the derivative. I'm not worried about that. I'll talk about that in just a second. We'll do it. But the biggest concern that I have is most of the people have trouble factoring it out. I've pointed it out a couple times in the chat. It's kind of hard to explain because all these exponents become very tedious to type. But let's go baby steps first. We're going to take the derivative of this expression and set it equals to 0. That's our objective. And while we're doing that, is to find the critical point of this function. Okay, that's our agenda. So if you want to do that, this is basically a product rule where you have to take derivatives of these two functions. So it'll be x to the power a derivative, keeping 1 minus x to the power of b as it is, plus x to the power a as it is, and then taking the derivative of 1 minus x to the power of b. That's the product rule, right? Any questions about that? I hope not. And this needs to be 0. So then now actually taking the derivative would give us a x to the power of a minus 1, 1 minus x to the power of b, x to the power of a, b times 1 minus x to the power of b minus 1, times minus 1 because of chain rule. So far so good, right? Okay, nice, sweet. So with that being said, now is the time to actually find those zeros and where, makes this function equals to 0. What you want to do though, a lot of people want to move this to this side. Okay, move whatever one side to the other side. I'm going to expand, simplify a little bit so that makes sense. So it'll be a x to the power a minus 1, 1 minus x to the power of b. I'm going to take that negative and make it negative b x to the power of a, and 1 minus x to the power of b minus 1 equals to 0. So that's the simplified version of it. And most of the people you've seen, they want to move this over to this side, cancel some stuff, and just kind of work it out that way. But this question is intentionally made for you to, be able to factor out things properly. The reason why I want to emphasize on that, because right now, it might not seem like a big deal. But when you'll be studying finding critical points of multivariable functions in the coming time, along with Lagrange multipliers, a very famous method for doing optimization with multivariable functions, you'll need to know these tools in order to, actually get the result the way you want it. So the correct way, the mathematically correct way, is to factor this thing out. Okay? In this, it might not look like there's something you can factor, but there is. And like you were talking about the result, I can show you what it means to rewrite that. This right here, x to the power of a minus 1, could be written as x to the power a divided by x. Do you guys agree with me on this or not?
Yes.
Easy, right? So this could be written as 1 minus x to the power of b minus 1. Oh, not b minus 1, just b divided by 1 minus x. Right? Same idea. So the exponent rule, no problem. An exponent rule works like this. If you have x to the power of a minus b, let's say, some reason, that could be written as x to the a times x to the power negative b. And this could, exactly, could be written as 1 over x to the power b, and then so on. So that's that. So now I'm going to bring everything else which was already there. So this was there, a was already there, and then 1 minus x to the power of b. And then negative bx to the power of a was already there, equals to 0. Now you can see there are clear factors there. This is a factor of both the terms, and so is 1 minus x to the power of b. So let's get them out of the way and see what we're left with. If you factor x to the power of a and 1 minus x to the power of b, you will be left with a over x in the first part minus b over 1 minus x in the second part. Do you see that? So far so good. I'm going to copy this over to the next page so that we don't spend time writing it. So this is what we have now. Now, when you're encountering these three factors right now, as if we say it, and these factors equals to 0, so what you have is either this factor being equals to 0, this factor being equals to 0, or this factor, a over x minus b over 1 minus x being equals to 0. There are three possibilities, right? This possibility yields you that x could be 0. This possibility yields you that x could be 1. And I don't want to go in there because that's trivial algebra. It will be a little hiccup for me to just jump right away, but take some time, observe this, and you'll be able to figure that yourself too. Okay, cool. The first two factors are easy, right? Good, let's go. So this one, when you have a over x minus b over 1 minus x equals to 0, first thing you want to do is you have to have x in the numerator, so you'll move this over there. And what I can do is I can take the reciprocal of both sides. I can do that. So this could be written as x over a, 1 minus x over b. Any questions regarding this? You can flip both sides, right? Yeah, exactly. So now we have it in this format that we have it in this side. So we can multiply both sides by b and a to get this particular result. So it's going to be bx equals to a with 1 minus x. Simply just bx equals to a minus ax. Moving this guy over here to the left side, or basically adding ax to both sides, you'll be left with bx plus ax equals to a. Factoring out the x leaves you with b plus a equals to a, leaving you with x being a divided by b plus a. Okay, so that's the case we're looking at right now. Now, this would be a critical point. So we got this. This is going to be my candidate for a critical point. But I have to make sure, conceptually speaking, that this critical point is going to be in my domain of interest. Because if it's not there, then there's no point in considering this. So how do you know if this is going to fall into the domain that was given to us? The domain was given was 0 to 1. Any guesses on this? And any guesses how you would prove? Yeah? Yeah, A and B are positive? Yeah, so that's good. Then what does that conclude? So the thing is, the way you want to see that, all I'm considering right now is to make sure if this point lies in this interval. Because if it's outside that interval, then we don't consider this, right? That's the biggest deal. So to have that here, since you said A and B are positive constants, it is pretty obvious that A will be smaller than A plus B. Do you agree with me on that? If everything is positive, right? Got it? And then if you divide both sides by, A plus B, then A over A plus B will be less than 1. So that's good. It's lower than this. And how do we know it's going to be bigger than 0? Because these are positive, then this needs to be bigger than 0 as well. So it kind of like inherently proved that this number that we got, A over A plus B, for any values of A and B positive numbers, will lie between 0 to 1. So this is something we want to pay attention to. Like, this is something of our interest. So cool stuff. Got that. Now that this is the critical point, you want to test if it's going to be a max or a min. Okay? But what you are lucky right now is when you're doing an interval analysis, which is the closed interval, you only have 3 points of interest to test. And I'll show that right now. So to summarize, my function was again x to the power of a, 1 minus x to the power of b. My interval of interest was 0 to 1. I got 3 possible candidates. I think we're looking for absolute max here. Yeah. So we got three possible candidates for absolute max. The first candidate is x equals 0, which is the end point, the left-hand point of the interval. Then you got x equals to a over a plus b, which is the, the critical point we got from our analysis. And then the last one is going to be x equals to 1, which is the other endpoint. So we got all these figured out for us. And now we're going to plug these things into the function and check what we're getting for results. So when you plug in this f of 0 there, 0 to the power of a, 1 minus 0 to the power of b is going to be 0. F over a plus b, this thing, I'm going to compute that in 1 second. Okay, I'm not going to do that just yet. I'm going to leave it for now. But if I plug in f equals to 1 there, you'll see it will be 0, basically 1 to the power of a, with 0 to the power of b, which will still be 0. So the argument I'm trying to make here is that this function is 0 at all these interval points. Okay? And in this particular location, it will be a positive number. I'm pretty confident about that as well. Okay? The reason why I'm confident here, because if I plug in that number, a over a plus b to the power of a, and do 1 minus a over a plus b to the power of b, this is a number that's greater than 0. I'm pretty confident. And this itself is going to be bigger than 0 as well, because we've concluded that this number is going to be less than 1. So 1 minus a number less than 1 will always be positive. Right? So by that, I can say two positive numbers we multiply, I'm going to get a positive number that's going to be bigger than 0. So that is the only possible critical point, which gives us an absolute maximum, because the endpoints already gives us 0. And this is the whole picture. Right? You see that? The only thing that was troublesome was to figure out these factors, right? Like if this was a little trick that you guys knew, it'll be easier. The reason why I don't advocate moving it over there and canceling, the terms, it's like a debatable thing you want to do that. Some people might be okay with that. But usually what happens is if you move it over and you try to cancel stuff out, you're going to lose results. And you don't want that. Okay? If you move that out, you'll be only getting this one single critical point, and these ones are going to be gone. So it's not a general good practice to do it. In this case, we're not going to consider them anyways because these are our endpoints. So one be like, okay, it's fine to move that over there, cancel stuff out, you still get the right answer, nobody's going to ask any questions, it's all good. But in a general world, I would not recommend just moving over and canceling these things out. Okay, and I don't know if you've checked out the little Desmos graph that I made about this, but I'll show you that right now. Well, that's how this one looks like in a general picture. So see, I've labeled my x critical point. As I change values of a and b, you can see that it still just kind of like always stays on the top. So that point is indeed the maximum, just to verify our result. And if you guys didn't know that you can restrict domain of graphs on Desmos by putting these curly brackets right here, as you can see. If you want to restrict, let's say, a function from 0 to 1, you just type the curly brackets 0x less than equals 2 less than equals to 1, and you can restrict that in a little piece over there. And that's about it. That's how you would do this problem. Any questions? Go ahead. So I don't know what they're asking for. If they're asking for where this function has a maximum, then it will be a over a plus b. If they will ask you for the maximum value, then you would have to plug that thing into the function and get that exact value. It depends upon what they're asking. I'm guessing they're only asking for the critical point, I guess. So there's no other critical point. If you choose x equals to a, in our analysis, let's say we're working at this point, how did you get x equals to a? That's my question. A minus a. Where do you have a minus x here? Because to make it 0, I know you're on the right track saying that a minus a will make it 0. But that for that, you need to have an a minus x there, right? The three factors of the derivative here, like this one is the derivative of the first part, this is the derivative of the second part. Neither of them have x minus a or a minus x, for the matter of fact, to make it 0. If you wanna send, you can send me your work. I can definitely take a look and point out where things went south. But I think it will be pretty obvious to figure that out. Yeah, if you would have had an x minus a in your numerator, in your derivative, that's just the numerator of the whole derivative, then yes, then x minus a would yield that x must be equals to a for it to be a critical point, but that's not the case. Derivative had some issues, probably miscalculated something. Yeah, that's why. If you want, I can double check your work too. If you want to send it in the channel, I'll be more than happy to take a look.